Hi everyone, this is the recording for Sprint 2 for EcoScan Team Algo Avengers. Next slide. Uh, in this in Sprint 2, the updates from the last sprint are the MVP, mostly the front end. The user stories have been updated and test cases and acceptance criteria. Also, we can see that we have some new project backlogs from Sprint 1 and we are going to cover them as well. The improvements from the last sprint that was suggested by the professor are the project schedule for all the sprints that we have added. Retrospective video for sprint 1 was added in the wiki page as well. We have also added the roles for each team members on the wiki page, and the naming the tools that were not named before in the wiki page and PPTs are named and what are they used for. Problem statement remains the same. Our application's MVP is to detect plant diseases, and same goes with personas. They're the same. Can you go to the last slide? Yes. So we have also been through this, but the existing models, we have added some of the features. We are thinking of adding some of the features from the other existing AI models, that is weather forecasting as well. Next. Next. So the tools we have used are Python, NumPy, OpenCV, Keras, Jira, TensorFlow, HTML, Visual Studios, and GitHub. Uh, Next slide tells us that what are these tools used for. So for front end, we have used HTML, CSS. Visual Studio is used for mostly it is a platform, so framework we have used it for. Figma is used for the designing of the tool. So we have designed the basic layouts of the web application, as well as how we are the login pages and every other design for the MVP on Figma. The backend uses Keras, NumPy, and TensorFlow. We have used Python as the programming language and Django for database. We have used tools like Jira, Teams, WhatsApp, and Git for all the management for the project. Sprint to schedule had deliverables such as architectural diagram, conceptual diagram, sequence diagram, user stories, acceptance criteria, Figma design, application test cases, sprint burn down charts and completed tasks, retrospective, prototypes, and demos. We have divided these tasks according to the expertise of each team member, and we have completed the sprint too.
Okay, further will be explained by me. Hi everyone, I am Omkar. So I will be explaining architectural diagram as well as like what both the architectural diagrams, conceptual diagram and sequence diagram. Let's go with the conceptual diagram. For the conceptual diagram, we have created a website where user will come. We have created basically 5 pages for user. First is home page. He will basically land on a home page. Then we have a about us page where we are showing what are the what we have created for basically user and what other things we are offering to him. Other is area details. Area details is comprises mostly of what particular area and what is the crops and soil looks like in that particular area. The next one is weather details. Area details and weather details are our functionalities. We are trying to implement those as a functionalities. Weather details will try to give weather forecasting for that particular region whenever user wants to see what is the upcoming weather for next few cycles. Next thing is our MVP. Our MVP is disease detection page where we are taking an input image from a user and then we are providing it to our CNN model. Basically, we are working on machine learning model where we'll accept images and we'll train on the we'll give an analysis back to the user. So this was our conceptual diagram. Next is a sequential diagram. So here is our sequential diagram. So user will log into our website. A user will come to our website and user will log in. Then website will send a request to our server, and we'll get a response if the authentication is successful or failure, so that after that a user can log into the website. Then later he can send upload the photo of an image. Later he can upload the image of a plant. Then again we'll request send the request to our server, where we'll store the photo, as well as again send the response as a URL to the server. Then server will send the URL to our ML model. ML model will analyze the image as well as uh, perform the task, and give the analysis, like send the analysis back to storage to the server as a response. And after that we'll send that response to our user, and we'll show the user what was the analysis for that particular image. So this is the sequence diagram for our disease detection system. That is our MVP for this project. And this is a complete scenario. We will be adding some few more functionalities, but since they are still, we are just discussing and trying to implement those, so those are not added in this particular sequence diagram. We have just created a sequence diagram which is completely related to our MVP. Thank you guys.
Yeah. Can you go to the next slide, please? Yeah, so to basically understand what is the database which we are using. So our database is New Plant Disease, which is taken from the Kaggle, which has 84,000 RGB images, on which we have like split data on 80% for the training, and for testing we are using the 20%. So from the data set, it were having like 14 different plants which are there, but initially we are just focusing on the some of them, which are strawberry, orange, pomegranate, apple, and kiwi. And there are other number of classes as well. So there are total 38 classes. If we exclude the healthy leaves, so there will be 26 different types of images which will help us to identify the diseases in the crops. So model which we initially tried to implement was the CNN model, but as you can see, the data set is very big. So we just shifted to the vision transformer model, as it will help us to give a proper understanding about the image classification. And as we are doing the image analysis, so it will help us to give a basic understanding of the NLP as well. So the model which we have built initially for the right now, is of just 6 layers, which consists of 1 layer of the vision transform, 2 flattened layers, 2 batch normalization, and 2 dense layers. And the model which we are going to evaluate is going to be the accuracy and the losses. And we are using the Django for the framework to connect with the front end. So next part, please. So yeah, so talking about the MVP, so this is the basic prototype how our each and every page is gonna look like. So this is the home page, in which like the user will come to this page, have a basic understanding like what we are, how what are the things which we are gonna do it. So basically it is a basic idea like what it like the user login page, the about us page, like what are the different areas which we are focusing, the new trends, how the technologies which we can be using. So from the home page, the user will be easy to, for the user, it will be easy to understand. Next, please. Yeah, so about us page. So this is a basic introduction page about us, like what we are and how we are going to be the differentiator from the others who are going to be the existing ones. As you know, there are many different, all the existing models which are easily obtained. So this page will basically give an idea like how the user who is going to be using our product is going to be benefit, like how we are going to be a beneficial from the other models which are easily available. It will basically have an idea about us as well, like who we are, and it will help of them to have a trust within us, so that we can just help them whenever they need a support from us.
Yeah, so I'll be discussing this. So this user-friendly interface is designed to let users select their area and immediately see pertinent soil information and suggested plantations for successful cultivation. With just a few clicks, our web app provides a deep dive into soil types and their compatibility with various crops, ensuring our users can make informed decisions for optimal planting. Turning to the weather forecast page. So turning to the weather forecast page, we are introducing an interactive feature that allows users to pinpoint their exact location for a personalized weather forecast. It's not only about data, but also about presentation. Our layout is visually appealing and user-friendly, making the comprehension of weather data a breeze. And we know that weather waits for no one. That is why our real-time updates feature ensures you're always in the loop with the most accurate forecasts available. And we have carefully crafted the design to be responsive. So whether you are on a desktop, tablet, or a mobile phone, you will have the forecast you need right at your fingertips. Next slide. This feature of the plant disease detection page is a fusion of simplicity and sophistication. Users can easily upload images of plant leaves and receive instant diagnostics. It's not just about identification, it's about comprehensive care. This web app provides the disease name, its stage, and tailored advice on precautions and remedies. Understanding the why behind disease detection and how of prevention is pivotal. Our platform educates and empowers users, enabling them to maintain plant health and prevent future outbreaks. With this tool, effective plant disease management is just a click away. Next.
Okay, so this will be taken up by me. Coming to user stories are the short description of the features that are required by the end user. And for the user stories, we are using a template as which goes like as a and the user role, and I want to whatever the feature the end user wants it. And we can see that we have three columns here with the user story, status, and place and feature. So coming to the first user story where a user wants to upload an image of plant leaf to detect diseases. The second one being as an user, I want to receive detailed information about the detected plant disease. As a user, I want to view prescriptions and suggested supplements for the detected diseases. The fourth user story being as a user, I want to know the various cures and preventive measures for the detected disease. And then the fifth one we have that as a user, I want to keep the history of previous detected diseases. So all these five user stories we have decided to be placed in disease detection feature that we will be working on. Coming to the next one, we have two user stories that will be placed under weather information, which will be where the user will be checking the current weather conditions of the area, and also the user would want to view the detailed reports of forecasting for the agricultural planning. After that, we have three user stories coming under agriculture details feature where the user would want to check the soil type and recommend plantations for his geographical area. The user would also want information about the suitable crops and growth conditions for his area. And then a user would want to see the latest news related to agriculture and farming practices. The last the second last one we have is as a user, I want to receive notifications or updates about my uploaded plant reports, which is to be done in the notification system feature that will be done on the website. And the last one we have a user story which will be featured in the agriculture information where the user would want to explore and learn about the new farming technologies and the practices. The next one will be continued by Mukesh.
Hello everyone, this is Mukesh Sudala and I'm here to explain about acceptance criteria of our project. So next slide please. So here are few test case scenarios and their respective criteria and summaries. So the first case scenario is where the user uploads an image for a disease detection. Here our criteria is the uploaded image must be in a common image format, like for example JPG, PNG, etc. And also it should contain a clear image of plant leaf so that the system can identify and analyze the image accurately and identify the plant disease. The summary for this scenario is to ensure that the user can conveniently upload the plant images for the system to provide accurate disease identification. Here is another case scenario where the user receives detailed information about the identified disease. Once the disease is identified, the system should display the name of the disease and the prevention supplements and also about the other relevant details which are relevant to the image. And also the user should be provided with the comprehensive information and with the detected plant disease information like preventive measures, disease stage, and also additional details for better understanding and management of disease. So the summary for this final case scenario is to foster user engagement and system improvement by following users' feedback and creating a dynamic and responsive ecosystem for disease detection. And about the test cases, our teammate Aishwarya will continue.
Hello everyone, I'm Uma Maheshwari, and here I will explain about the test cases, which is really important for any software development in order to make sure that our product is reliable and working properly. Here we created like 9 units of test cases in order to test the features that were given in the acceptance criteria. And here coming to our first unit to test, that's image upload functionality. In each unit of test, there will be different scenario test cases. And for our first one here, it is user uploads a valid image of a plant leaf. So when the user uploads a plant leaf, it should identify the disease, display prevention supplements, what stage the disease in, and the details of the disease. This feature is still in progress and our team is still working on that. And our second scenario in unit to test for image upload functionality is when the user uploads an invalid image format. So when the user uploads an invalid image format, the system should prompt an error message indicating the unsupported format, saying that the image is invalid. And our another scenario to be tested is user uploads an image that is not a plant leaf. If the user uploads an image that is not a plant leaf, like it may be an animal or just maybe a teddy bear, whenever someone uploads an image that is not a plant leaf, it should prompt an error. And that error should be different from the error that gives if the image format is invalid. That is also giving us the result desired for now. Here, the unit to be tested is user interface and navigation. So when the user navigates through the website without uploading an image. So when a user tries to navigate the website without uploading an image, it should allow the user to go through the website just to see what is there and what's happening and what they can do. So the system should provide a user-friendly interface with clear navigation options. And the another scenario to be tested when user attempts to access restricted areas without proper authentication. So if the user tries to access any restricted area, it should ask for the user login details for his username and password for our website. And that another unit to be tested, prevention supplements information. So here the scenarios are when the user views prevention supplements for a specific disease, the system should display accurate information on prevention supplements for the particular disease on the plant leaf. These features are still in progress. Next slide, please. Here are our last 2 units to be tested when the user profile and preference. When the user updates their profile information, they should be able to update the profile information in the system. And they should be able to get the notification alerts if they want to, or if they don't want to, they can do that. They should have that option in their hands in the system, which is still in progress. And the feedback and support. When the user submits feedback through the website, then we should be able to receive the feedback and store it for future analysis. User access the support section for assistance. The system should be able to give the support information and contact details for the user in order to navigate more clearly. And if they have any doubts, they can clear them more properly. Next slide.
Hi. So the burn down chart, the actual burn down versus the ideal burn down chart. So we can see that we have started this sprint on 22nd of the last month, and today is the 13th. Initially we were a bit behind on our task, and we started working on the projects in the coming week, and we updated the tool as well to get the burn down charts corrected. We in between project, in the middle, as you can see on the 1st of March, we had a dip and we were doing more work than we were supposed to, and then the chart follows. Next.
Yeah, hello everyone. I'm going to continue this retrospective part. So we use idea board as for the retrospective part. Like here we are coming with the points for the what went well and what can be improved. So after getting all the points from all the team members, we're gonna take like votes on the each point. So at the end, like whichever the points have like higher votes, we are gonna bring them into the action items. Action items are nothing but we should get improved on these points in upcoming sprints. So next slide. Okay, coming to the what went well. So we are very happy with the front end part. Like we got a good front end part as we plan and design, and the multiple iterations of design to understand better approach. And the next one is like helping other team members when stuck at point. So we face some problems when like some of the team members face that any problem in the middle. So we as a team members we help each other to solve the problem. And next, goals for the sprint 2 were clear and giving regular updates on assigned work to make sure everyone is on the same page. So these are the points went well. And coming to the next slide. Yeah, what can be improved? Like, so we are coming up with the 4 points that we should improve mainly in this by this sprint 2. So the first one is like making sure that we get connected well on the Jira and the Figma parts. Like we did not use the Jira tool regularly in this sprint, so we are gonna improve this thing. And backend development needs to be improved. So in this sprint, we majorly focus on the front end. So the backend work is going less. So we're gonna improve that. And the third point is like better communication for task completion and attending meetings by all team members on important days as fixed. So these are the things we face in this sprint 2. And the next slide, action items. So updating things on Jira, as I told you, we should improve a lot in this tool. So we are gonna do this in the next upcoming sprint, and GitHub activity to be updated on server then local machine, understanding the actual requirements of the MVP. And the fourth one is like better understanding of ML models and data to reduce time and data leakage because of unclear data. So we are going to improve these things in the upcoming sprint. Yeah, that's it. Next slide.
Okay, further will be explained by me. So plan for sprint 3. So plan for sprint 3, as we have worked rigorously on the front end, so now we are a little bit lacking on the back end side. So for us, making a CNN model and like a machine learning model which will take the input as well as the backend connectivity with front end and database, we have to improve that. Then we have to definitely make sure how we are storing the data, like what are the things we are storing on database and how we are going to make a login page for user and login authentication. So we have to figure out that for this sprint. And upcoming sprint will also add more user stories and test cases as we improve with the connectivity and as we get better with our application, as well as we'll work on, there are few front end things we have to improve, such as the pages currently have a basic data but we have to give a proper data, so we have to connect with that. So this is the plan for the upcoming sprint. Next will be project demo, which is already uploaded on our GitHub wiki page for Algo Avengers. And this is the link for our wiki page. And thank you so much for being here, everyone. We would like to end here our presentation.
Thank you.
Thank you.
Thank you, everybody.
Thank you,
everyone.
everyone.
Thank you.